Okay. All right. Basically, what we're going to be looking at today are how to. Now we've talked about how to find the area. Get rid of the gum. We found the area of parallelograms, trapezoids, rhombuses, and kites. Those are all special types of polygons. But what if we have a 5-sided figure, or a 6-sided figure, or a 9-sided figure? We don't have a special dedicated formula to find the area of that particular polygon. So, what we're going to, we have a special formula that we're going to use but I want you to first understand a little bit of vocabulary. So I have 2 vocabulary terms. One is the radius of a regular polygon. Basically, a polygon is you can inscribe polygon. You don't have to draw that part, but just understand that you can have a polygon, a circle, circumscribed around a polygon. And if I draw a point from the center of that polygon out to the edge of the circle, what do we call the line that goes from the center of the circle? Circumcenter. Radius. It's a radius. That's right. So if you draw this, this line is the radius of a polygon. So it's a line segment that goes from the center of the polygon to its edge, to a vertex. Because if it goes to the edge, it's not would not be the radius of the circle. Yeah. They're all radii, yes. Okay. On the other hand, if I draw a segment from the center not to one of the vertices, but to the edge of the polygon, it's a perpendicular line, and we call that the apothem, or apothem. I call it the apothem. So it's a line segment, a perpendicular line segment from the center of a polygon to its side. Well, because if the line goes from the center out to a vertex, it's also on the edge of the circle, which is what makes it a radius. It forms a 90-degree angle with the side of the polygon. Okay, now, to find the area, of a regular polygon, we use the formula 1/2 A times P, where A stands for a apothem, and P stands for the perimeter. So first we're gonna have to figure out these two things, or sometimes they'll give us some of the information, and sometimes they won't. Okay. Yes.
Is that just like how would you find that?
We'll talk
Or will
about
that be given?
Sometimes it'll be given, sometimes we're gonna go over how to figure it out.
Those are just kind of triangle and half things? Bisects, never mind.
It does. Okay. Now let's do an example. Okay? So let's pretend that the apothem is 8. And that one side of my pentagon is equal to 6. Okay, so this is 8, and this whole side is 6. Alright, so we have to do, now, in order to use this formula, we need two pieces of information. We need the length of the apothem, and we need to know the perimeter. Well, the problem tells us the length of the apothem is 8, but it doesn't tell us the perimeter. So we have to figure out the perimeter. So we have a formula that we can use to find the perimeter. So that formula is simply n times s. So the perimeter of a polygon is n times s, where n is the number of sides, and s is the length of one side. So you take the length of one side of your figure and you multiply it by the number of sides. Very straightforward. Okay, so what's the perimeter of this pentagon? Who said that? The perimeter is 30. How do we know that? Well, if one side is 6, how many sides in a pentagon? 5. 6 times 5 is 30. So now that I know that the perimeter is 30, I can apply that to my formula, 1/2 a times p. So the area is 1/2 a times p. So it's 1/2. My apothem was 8. My perimeter was 30. So I get 1/2 8 times 30, which is 1/2 times 240, which is 120. And it's going to be, again, whatever units. So if we're using inches, my answer is going to be 120 square inches. Yes, sir?
That's for us.
Yes. All right, so I'm going to give you one, but I'm going to have to change the homework because we're not done with today's lunch. Okay, well, while you're working on the problem, I'll change the homework. Does anybody have any questions? Okay, what I'd like you to do is find the area of a